Okay, we're going to now start on animating characters. The character controller we talked about last time was for simple cubes and so forth. But of course, we're more interested in moving around humanoid characters, things that we want to have walk, jump, run, shoot, do all kinds of different stuff. And for this, we use something called the Mecanim system. Let me get my slides going here. So Mecanim animation is based on animation clips. We made some ourselves, but character content often comes with animations that were built in Blender or some other program. These clips usually are comprised of a simple piece of motion, such as running, walking, jumping, whatever. And they're usually part of the imported FBX data from our character that we get. And one of these animation clips looks something like this. We've got the start frame, that's right there, and the end frame, that's right there, because often these animation clips have more than one part to them, or they'll repeat the motion over and over again, and you have to trim it down. And as you do this, a couple of spotlights here show you how well it's looped. If you're a walking animation, you want it to loop properly so that the walks don't have hiccups in them, and other things that are indicated by these red lines. It has a lot of properties here, looping, how it's based. I'll let you read about that in detail in the documentation. The other thing that we need for our Mecanim animation is an animator component, not an animation component, but an animator component. And this has a couple of things that we need to look at. One is the controller and the other is the avatar. Interestingly, the real meaning of the word avatar is a manifestation of a deity or released soul in bodily form on earth, an incarnate divine teacher. And it comes from the Sanskrit word avatara, or descendant. I just love that. Back to Unity. The Animator Controller is what we're going to use to set up the behavior of our character. The Animator Controller is a state machine. It's going to have different states and blend trees and transitions and potentially events and other things that we'll talk about as we go along here. You can create an Animator Controller window. You can create one, and it'll look like this in the project view. It has a little icon for a state diagram. And once you've made this controller that has the different states and transitions, you can drop it into the animator component of any character with an avatar. And we're going to see this as the ability to set up animations for one character and then use it on many humanoid avatars. So a controller looks like this. It's a state diagram. It's got various states, the little squares, and it has transitions, the little arrow lines between them. It has parameters that we can set from scripting and use that to control our transitions. We also have layers that I'll talk about later. These parameters are variables that are defined within the animation system, but mainly we manipulate them from scripts. A parameter could be updated with a curve, then accessed from a script that picks a value off that curve, and so we can control the pitch of the sound effect or whatever. When we see blend trees, we can also have a parameter that controls the blend tree. Parameters come in a number of different flavors. You can have an integer, a whole number, a float, a number with a fractional part, Booleans that are true or false, and triggers, which I won't really talk about. You can read about them yourself. Parameters are assigned in a script using functions like set float, set int, set bool. These are kind of obvious. So a simple example here, I'm going to set up a character that runs forward. So in my script, I have a private animator of type animator, which I get a cached copy of in the start function using getComponent. And in update, I'm going to get the horizontal and vertical axes, and I'm going to set its speed as h squared plus v squared. So let's look at that. This is here's the controller for this. Where's my character? Here's my character. Has an animator. It has a controller. 0, 1 run. 0, 1 run has these states and transitions. I'll talk about all of these in a minute. Important here is this speed. That's the thing that I'm setting in the script. And the speed is going to be used to control the transition from idle to run. So let me just play this so that we can see it in action. Here's my little character. Run is triggered with the up arrow. So I start running. And you notice we can watch what's happening over here in the controller. Right now it's idling, so the idle animation is playing. As I run, it transitions to the run, which is a looped animation. So it's triggering over and over and over again. And I don't want to run off the edge of the world there, so I'll stop. So that animator set float speed to h squared plus v squared, that's the thing, that's the parameter that is appearing here in my speed that is controlling this transition that I'll talk about in a second. Let's watch the speed here. Watch this speed as I run, and you'll see the speed goes up to 1 and then drops back down again. I can actually make it go 2 by pressing the horizontal axis 2, but it's not using that, so it doesn't matter. So these animation states, these building blocks of our state machine, each one contains an individual animation. And the events in the games, when we change that parameter, that triggers a transition. It transitions from one state to another. The basic idea is that a character is in some particular action all the time, and these actions depend on what the gameplay is: walking, running, idling, jumping, whatever. The character in general has restrictions on what the next state it can go to. For instance, a running jump could only be taken from a character that's already running, not when it's standing still, idling. So it should never switch straight from an idle to a running jump. Taken together, this whole set of states, the set of transitions and the variables or parameters that define the current state, form this state machine. And often when thinking about these, we represent as some kind of graph. From idle, we can go to standing jump, and from standing jump, we can go back to idle. From idle, we can go to walk. From walk, we can go back to idle, or from walk, we can go on to run, and so forth. That kind of state diagram, and Mecanim allows us to build this directly with all the arrows and everything. This requires very little coding. It's really a tremendous tool. Each state has some motion associated with it that plays when the machine's in that state. And this enables us to design complex motions without having to do any coding at all except to set the parameters. An animation controller has these states, transitions, and possibly events. We can actually make sub-state machines by grouping a bunch of them together and calling it a single substate. And when we select one of the states in the controller, we see the properties for that state. We see what animation is included. We see its speed. We see what transitions from this state are. It can go from run to jump, and this has 3 transitions out of it. In my little state here, the idle has the idle function. This is one of the animations over here that I can see. It just stands there and does nothing. But the run state has a run animation. I can see the run animation here. It runs forward. It's looping. And these are all part of my little character here that I'm playing with here. So each of these states have an animation clip associated with them and transitions. The run can transition to idle. The idle can transition to run. We have a default state. This is the yellow one. This is the state that we transition to automatically from the entry state. We also have an exit state that immediately recycles us around to the entry. We have a default state that we can set as default. The solo and mute let us isolate things for previews. And we can create a state by clicking on the Animator Controller window and selecting Create State Empty. This way we could then define in that empty state what motion it has and its transitions. You can also drag an animation from your project view into the Animator Controller, but be warned, this only works with Mecanim animations. The any state we can also use. This is a special state that exists for a situation where you want to go to a specific state regardless of where you are, what state you're in. This is kind of a shorthand for adding outward transitions from all the states in the machine. And because it's in any state, you can't go to that state, so it can only have outward transitions. I'm not going to use any of those here. So the transitions. The transitions define what happens when you switch from one state to another. And these, only one transition can be active at any time, and the condition that controls that transition can be an exit time when the animation has completely played. Actually, you can specify how much of the animation is played with the exit time. 0.95 would mean that 95% of the clip had played. But more often we use conditional predicates. For instance, our parameter is less than or greater than or equal to various floats, or if a Boolean is checked. So here's the transition for the out of idle. We transition out of idle if the speed is greater than 0. That's our condition, speed is greater than 0, and then it's going to transition out. Um, you can adjust the transition between the two clips by dragging this stuff around. So the idle plays along here, then it goes into its transition, whose duration you can set by moving these little sliders around. It transitions into the run, and then it's in the run animation, and you can get a preview of what this looks like here as it transitions from the run. You can actually move it back and forth and see how the transition runs. This little white line is kind of a measure of the center of your character, and so the blending can sometimes can help you to line up those lines as it transitions from one state to another. This is a bunch of fiddling. You just have to fiddle to get it to look right, to make the steps match up and other things. Animation transitions.